Assalamualaikum and hi, my name is Ezra and my final year project title is The Dynamics of Strictly Non-Volterra Quadratic Stochastic Operators on the Two-Dimensional Simplex. This study focused on quadratic stochastic operator or QSO, which are nonlinear operators used to describe the evolution of population over time. In this research, the population state is represented on the two-dimensional simplex, which contains all probability distribution for three species. My study specifically considers strictly non-Volterra QSO, where offspring are always of a type different from both parents. Because of this condition, the system produces more complex dynamics compared to the classical Volterra case. The first objective of this study is to derive the canonical form of strictly non-Volterra quadratic stochastic operators on the two-dimensional simplex. The second objective is to compute and analyze the trajectories generated by these operators. From the literature, previous studies by Bernstein, Lubitsch, Mukhmedov and Ganifjev, and Zamilov and Rokikov show that QSO are important in population genetics and nonlinear dynamical systems. Earlier studies also show that strictly non-Volterra QSO may produce oscillation, pedicity, and complex long-term behavior. However, explicit analysis of trajectory behavior on the two-dimensional simplex is still limited, which motivates this study. In terms of methodology, this study used both theoretical and computational approach. First, the canonical form is derived by applying the strictly non-Volterra condition to the general QSO. Then, trajectories are generated iteratively using the relation x power of t plus 1 equal to v x power of 2. Computational simulation is used to extend the iteration up to 1000 or 10,000 steps. For the result, the study first obtained the canonical form, which depends on 6 non-negative parameters under normalization constraint. Next, for case 1, which is the one-parameter subclass, the system was analyzed for different values of lambda. The results show that the most value of lambda, the trajectory has heavy persistent oscillatory behavior and do not converge to a fixed point. However, for lambda equal to 0.5, the trajectory approaches the center of the simplex. For the case number 2, which is the two-parameter subclass, the results show a different behavior. For example, when lambda 1 equal to 0.1 and lambda 2 equal to 0.2, the trajectory alternates between two distinct states after many iterations. This gives numerical evidence of a period 2 orbit. Similar behavior is also observed for several other parameter combinations. In conclusion, the study showed that strictly non-Volterra quadratic stochastic operators have rich dynamical behavior including oscillation and pedicity. The results also show that both parameter values and initial condition influence the long-term dynamics of the system. Thank you.